Okay, welcome back. This is Mr. Hassan's Maths channel. I'm now answering question number 11 from the May-June 2023 IGCSE Cambridge 0580 paper 2, variant 2. And this question here is about this kind of part of a sector of a circle. It's like you can think of it as a bit out of a donut. So the diagram shows a shape ABCD formed by the sectors of two circles with the same center O. Both sector angles are 140, so this angle here basically is 140 degrees. Okay, and OC equals 3.2 and CB equals 2.6, which means the radius of the smaller circle here is going to be 3.2 as shown here. All right. But the radius of the bigger circle is going to be the sum of those two. So it's going to be 3.2 plus 2.6, which is going to be 5.8 centimeters. That's the radius of that big circle. So it says both sector angles are, yes, OC is 3.2, CB is 2.6. The area of the shape is K pi centimeters squared. Find the value of K. So basically they're asking us to find the area and leave it in terms of pi and write down what constant pi is being multiplied by. So one way to try to understand what to do here is to visualize the situation. So I've prepared something here to make it a bit easier, hopefully for you. And what we can think of is the area that we need, which is this shaded part, is like the area of the whole of this circle, as it's one big circle, taking away this part here. If you find the area of the whole circle, the whole sector, and you subtract from it the area of this part, you take that area away, you're left with the shaded area. Okay, so it's the whole thing, okay, which we would find by, now we know the area of a sector is given by the formula theta over 360 times pi r squared. Why? Because a sector like this is, if this is the angle theta, a sector is a part of a whole circle. Right? It's like a fraction of a circle. Okay, so we want to find the area of just this fraction of the circle, which makes an angle of theta degrees. Okay, in this case it will be 140. And the fraction that angle makes with the whole circle is theta over 360, because the whole circle has got an angle of 360, one revolution. So the same fraction that the angle makes with the whole circle is the same fraction that we need of the area of the circle. It's kind of like proportion. So that sector area is given by this formula here. Now, in our case, the area of the big, section will be theta, or you can say 140 over 360. In fact, I'll write the steps here. It'll be 140 over 360. Okay, times pi times the big radius squared. Okay, which is 5.8 squared. And then you're going to take away the area of the small sector, which is this. Okay, the small one, which is going to be also 140 over 360, because it's the same angle, times pi times, and this will be 3.2 squared. Okay, so it's going to be, basically you can think of it as theta over 360 times pi times a big radius squared minus theta over 360 times pi times a small radius squared. This is like the big radius. This is like the small radius. So actually we could make it a bit easier on ourselves by rewriting it like this. 360 times pi times r squared minus small r squared. Okay, so I could have done that here, made it a bit easier so that I have to keep writing this down. And I could just do this, and that will make life a bit easier for me. Okay, so I can write this as a bracket here. Instead of that sign, I can put a bracket here. So I have 140 pi over 360 times 5.8 squared minus, and the radius of the small part of the circle is 3.2 squared, and that will give us the required area. Now we're going to leave our answer in terms of K, so I won't use the pi in my calculator. I'll just put 140 over 360, and I'll put times 5.8 squared minus 3.2 squared. And that will give me 91 over 10. So you have 91 over 10 pi. You can write that as 9.1 pi if you want. That's fine. Okay, so we want to leave it in terms of pi. So we want to find what this k is here. All right, this constant is here. So k is 9.1. They only want the, it says k pi centimeter squared. So they just want the value of k, which is 9.1. So you don't write 9.1 pi. You don't write down the value of 9.1 pi. You write 9.1. And there's the answer to this question number 11. Okay, so this is a question about area of sectors of circles, and pretty straightforward. 3 marks, and that's it. So I'm going to answer the questions from these papers question by question, so I can save them according to the playlists, as well as the paper playlist to do the topic as well as the paper. So you want to see other questions from this paper, you can go to the playlist, which is over here, and questions I've answered from this paper will be found there. If you want to find other questions dealing with areas and basically areas dealing with circles and sectors, segments and things, you can find in the playlist over here. You can subscribe to my channel by clicking on this link, and you can watch a video here which tells you how to use my channel to find things that you might be interested in. Thank you for watching, and see you soon.